Module, I'll be referring relief on topographical maps. Relief refers to the shape of the land. It is the difference between the highest and the lowest points in an area. The main technique used in topographical maps to show relief is contour. Contours are lines joining places having the same height above or below a reference level, such as mean sea level. Let us take a contoured line. I have drawn this line using brown color. Contoured lines are drawn using brown colors and they are usually numbered. This 100 refers to contour height. That means height of the contoured line above mean sea level in meters. So all the places lying on this line, they are of equal elevation or height, and the height is 100 meters above the mean sea level. Let us take a pattern of contoured lines. You can see that only two lines are numbered. This is the lower contour and this is the higher contour, 200. All lines are not numbered, because if we number all the lines where you have too many contour lines, it becomes congested and therefore we will not be able to show any other features. The contours which are numbered, and you can see they are darkened, these contours, they are called index contours. Usually index contours, they are drawn at a difference of 100 meters. And contour lines are drawn at an interval of 20 meters. So if this is 100, the next one will be 120, next one 140, 160, 180, and so the next one will be 200. The Survey of India prepares topographical maps using contour interval either 20 meters or 40 meters. Normally in ICSC, the maps that we will be using, 45D by 7 and 45D by 10, the contour interval is 20 meters and it will be stated in the topo sheet. So contour interval is always given in 20 meters. Interval will be of 20 meters. The definition I have written here, contour interval, which is represented by CI. It is the vertical difference in height between two adjacent or subsequent contour lines. Let us take the topo sheet. You can see here, these are the index contours. And in between two index contours, you will find four other contour lines. And these index contours will be numbered. The number will be written outside, like this is 1200. Then we have 1300. Then we have here 1400. So these are all index contours. They are drawn at an interval of 100 meters. You can check here, this is one index, this is another index, and in between there will be four lines. And The contour interval will be stated, contour interval 20 meters. Now let us take some fundamental rules of contour lines. There are 5 fundamental rules. The first one, contour lines join places having equal elevation above the sea level. So that means if I draw a contour line and a number will be provided to it, this is called the contour height. So all the places, if we consider all the places like A, B, C, D, E, F and so on, their elevation will be 100 meters above the sea level. We take the second rule. Contour lines of different height will never cross each other, but they can merge with one another. And this merging of the contour lines can be seen where you have a cliff, a waterfall, or where you have a hanging valley. Contours of different height. So let us take here, let us take this is 200 and let us take another line, contour 100. So they will never cross each other. That means you will not have any contours like this, 200, 100. Never. You will not have this. Rather, they may come and join each other like this. This is 200 and this is 100. So at the point where they merge, it can be a cliff, it can be a waterfall, or it can be a hanging valley. So normally in 45D by 7 and 45D by 10, we do not have hanging valley. Hanging valleys, they are found in areas which is glaciated. So here you may come across a cliff, you may come across a waterfall. A waterfall will be indicated on the map using this symbol. Suppose this is a stream and a black line will be drawn across it and it will be written falls 20 meter. So this indicates that there is a waterfall and the height of the waterfall is 20 meters. We take the third rule. Contours of same height cannot merge and continue as one line. However, they can run parallel to each other. So if we take two contours of same height, same elevation, that is 200, another one we take it as 100, these two will not merge, but they may come very close to each other like this, very close to each other, but they will never merge. Crossing is out of question. Contour lines, they will never cross. If the contours are of different height, then merging, they can merge with one another. But if they are of same height, this is 200, this is 200, same elevation. If we take the contours of same elevation, 200, 200, 200 and 200, both same elevations. So they will not merge, rather they will run parallel to each other. The fourth rule, the spacing of the contour lines indicates the nature of slope. So if contour lines, they are drawn very close to each other like this, if they are drawn very close to each other, This refers to a steep slope, and if they are drawn far apart like this, then this refers to a gentle slope. So spacing between the contour is very, very important. You can take this, suppose if I have taken this as 100, the next one will be 120, next one will be 140, and this one will be 160. And if we take this as 100, the next one will be 120, and next one will be 140. Now you see the distance between these two. Here the distance will be more, and here the distance will be less. So that means the gradient will be steeper here, whereas the gradient will be gentle. So by looking at the spacing of the contour line, we can know which one is steep and which one is gentle. We take the fifth rule. Contour lines should either close in on themselves or begin at one side of the map and end at another. Contour lines do not start or end in the middle of the map. So let us assume that this is the topo sheet. This is the topo sheet. Let us assume that this is the topo sheet. If you have any contour, a contour will enclose itself inside the map like this. Actually, all contours are enclosed. You will never find an open contour. Or you may see a contour line entering from one side and leaving the map from another side. Like this. Actually, this contour is enclosing outside the extract like this. It is enclosing outside the extract. Okay, it is enclosing outside the extract. But you have this part of the topo sheet. So that's why it appears to you as if the contour is entering from one side and leaving the extract from another side. Never you have a contour which will start from middle or any contour which will end in the middle. Now let us take gradient. Gradient is the degree of steepness or the slope of the land between 2 points along a given distance. Now normally we are asked to find out the gradient between 2 points on the map. So for calculating gradient, we will be using this formula. Gradient is equals to Vi upon He, where Vi stands for vertical interval and He stands for horizontal equivalent. Let us take the definition of vertical interval. In short, we may write it as Vi. So it is the vertical difference in height between any two contours. Between any two contours. It is different from Ci. Ci, that is contour interval, and vertical interval is not same. In contour interval, it is the vertical difference in height between two adjacent contours, whereas here in vertical interval, it is the vertical difference in height between any two contours. That is the difference. And the next one is horizontal equivalent, He. In short, we write He. So it is the horizontal distance between 2 points on the map and its equivalence on the ground. So first we calculate the distance on the map. So once we calculate the distance on the map, we convert it to ground distance using the scale. So that's why it is written here, horizontal distance between 2 points on the map and its equivalence. That means when we convert it into ground distance. And we will be doing so by considering the scale of the topo sheet. Now let us take two contours. This is 200 and this contour is 100. So this is the lower contour and this is the higher contour. And let us assume 2 points, A lying on the contour 200 and B lying on the contour 100. And this is the distance on the map. It is 4 centimeter. And this is the horizontal distance. We have taken the shortest distance. And therefore, let us take the formula gradient VI, vertical interval. So what is the difference in height between A and B? So let us consider the contour. A is at 200 meters and B is at 100 meters above the sea level. And therefore the difference will be 100 meters. HE is the horizontal equivalent. So we have calculated the horizontal distance between these 2 points A and B. This 4 centimeter is the map distance and we will convert it into ground distance. So after converting into ground distance, it will be 2 kilometers. Now since it is a ratio, therefore units has to be made same. So in the numerator it is 100 meters. In the denominator, by changing the unit to meters, it comes to around 2000 meters. And therefore the ratio is 1:20. So this is the gradient, 1:20. It means, so the same figure I have taken here. This is the position of A and this is the position of B. And this is the horizontal distance and this is the vertical interval, 100 meters. And the ratio and the gradient is 1:20. 1:20. So that means 1 unit increase in height for every 20 such units traveled horizontally. 1 unit increase in height for every 20 such units traveled horizontally. So if we take the unit as meter here, if we take it meter, so if we travel 20 meters horizontally, the height will be raised by 1 meter. So if we travel 20 meters horizontally, suppose this is 20 meters, height will be raised by 1 meter. And so this is the slope. This is the slope between A and B. Now let us interpret few relief features using contour lines. The first one is the concave slope, and I have drawn a pattern of contour lines here. You can see this is the index contour 100 and this is the index contour 200. You can clearly see that contour lines are widely spaced at the lower part but the contour lines, they come closer together towards the top, and this will indicate a concave slope. So it's a very common type of slope. So first gentle, I'm showing you the cross section here. First gentle, and then as you go higher up, it becomes steep. So this is what we call it as concave slope. The next one we take convex slope. So same way I have taken 100 contour, index contour 100, and this is index contour 200. You can see in the lower part the contour lines are closer together, but as we go higher up, the contour lines, they become widely spaced. That means this is gentle and this is steep. So let me take the cross section. It's not a very common type of slope. Lower part will be steep, and as we go higher up, it becomes gentle. So this convex slope is just opposite to concave slope. This is a conical hill, and you can see that contour lines are arranged in the form of concentric circles. So as we go higher up, you can see this is 100 contour and this is 200 contour, and in between you have 4 contour lines. So it is conical, just like a cone. The next feature refers to a plateau. Plateau, they are also called tableland. It's a large, fairly flat pieces of uplifted land surrounded by steep slopes. So it will be flat at the top, and since it is flat, you don't find any contour lines. Now you can see here the contour lines, they have merged with one another. That means there is a cliff. This is a ridge. It's a long, narrow range of mountains or hills. So I've just taken one part of it. You can see that the contours are long and elongated. That is how we recognize a ridge. So whenever you come across long elongated contour lines, it refers to a ridge. And there is another indication for a ridge. You will have streams flowing on either side like this. A ridge is also known as water divide or watershed. So streams will be flowing in opposite directions, in all directions like this. So if you have a feature like this on the topographical sheet, that refers to a ridge. Next we refer to an escarpment. See, there is a difference between an escarpment and conical hill. In conical hill you have concentric contours. Here in escarpment you see the contours are drawn in a manner that one side it is narrowly spaced, another side it is widely spaced. That means this side it is steep and this side it is gentle. The steep side we call it scarp. Scarp refers to steep slope, whereas the gentle slope is referred as dip. So when you have a highland having one side gentle, another side steep, then we will call it as escarpment. We will not call it conical hill. We will be referring it as escarpment. Next we take these three features: col, saddle and pass. In ICC there is no distinction. That means if it is a saddle you can write col, or if it is a pass you can write saddle. So no distinction in ICC. But there is a difference between col, saddle and pass. Normally saddle is among low hills. So you can see there is a contour pattern is here. So this 2 refers to peaks, and this is the low lying region between 2 peaks. So if you take a cross section, a saddle will be like this. So this is a peak here, another peak, and this is the low lying region. It's not a valley. Saddle is not a valley, but it is a low lying region between 2 peaks. So therefore this will be depicting this peak, and this will be depicting this peak, and this is the low lying region. So that is what we call it as saddle. The same feature, if it is among high mountains, then we call it col. So since it is among high mountains, so number of contours will be more. So I have just taken the contours, I have not completed the whole thing here. So you can see the number of contours will be more here. In saddle we have taken only few contours. That means it is a low hill. But here the number of contours are more, and therefore it is higher. So when it is among mountains, then we call it col. And col, this is the col, this is the low lying region. So this is one peak, another peak. This is the col. So normally col will have 2 streams flowing on either directions. So if you come across a feature like this, then it becomes col. Now when these 2 river streams, they will cut at each other due to backward or headward erosion. Any stream or any river can elongate its length by cutting at the back. So when this stream cuts at the back, let us take this stream as A and this stream as B. So both will be cutting at the back. This stream will be cutting in this direction, and this stream will be cutting in this direction. So when they cut at each other, that will lead to the formation of a pass. And a pass, this is the difference between col. You see col, their streams are there. But in the pass you don't have streams, because these 2 valleys, they have joined. And it is also a low lying region between 2 peaks. So if you take these 2 as peak 1 and peak 2, and this is the low lying region. And pass is very important because it is a means for communication. Like in the Himalayan region, we have some important passes through which we can cross the mountains. Otherwise, it is not possible to cross the Himalayas. Let us take this pattern of contours. You can see that the pattern is V-shaped. So actually, if we have a V-shaped valley, then you get the V patterns, and if it is a U-shaped valley, then you get U patterns. So you see the patterns are V-shaped. This is the lower contour, and this is the higher contour. Now here we are going to distinguish which one is the spur and which is the valley. Valley is a low-lying region between 2 mountain ranges, whereas spur is a portion of the highland which projects into the surrounding low-lying region. So valley is a lower region, whereas spur is a higher region. And between two valley you have a spur, and between two spur you have a valley. Now how to identify them on the topo sheet? By seeing the pattern of the contours. So there is a rule here. The rule is, since it is a V pattern, if you refer to the alphabet V, this point is called the apex. This point is referred as the apex. So if apex of V is pointing towards higher contour, then it refers to a valley. Like let us take this. This is the apex of V. Now this apex of V will be pointing towards higher contour. This is 100, it will be pointing towards 120. This will be pointing towards 140. This will be pointing towards 160. And this will be pointing towards 180. So therefore this is a valley. And this is the direction of the stream. A valley will be always accompanied by a stream. Now to identify spur, let us take this rule. If the apex of V points towards the lower contour, if apex of V points towards the lower contour, then it is a spur. Let us check here. This is the apex of V. This is 180. So this one apex is pointing towards a lower contour, that is 160. This is pointing towards a lower contour, that is 140. And this is pointing towards a lower contour, 120. So you see this is a spur. That is how we identify. In the next module, I'll be referring to the topo sheet to identify the various relief